Today is Monday, May 24th, and this is the last day of first period class for Math 2, and we are going over our final exam review. For number 1, we did the quadratic formula, which we have over here off to the side. We have to identify what A, B, and C are, and then plug them in to simplify our equation. We have to understand that in our final answer, the -3 out front is not going to change signs. It's the square root that's going to change signs. Excuse me. For number 2, when we're completing the square, we have to recognize the format of a perfect square trinomial, which I have there in blue, a squared plus 2ab plus b squared. But also connecting that to what we know about the standard form of a quadratic, ax squared plus bx plus c. So when we talk about c, that's the constant on the end, and c is always equal to half of b squared. So whatever that term is in the middle, we divide it by 2, and then we square it. So the value to complete the square for number 2 is 49. So I add 49 to both sides of my equation. I factor my perfect square trinomial into a squared binomial, and I notice my answer choices do not have a constant term on the left side, so I move my constant and I get x plus 7 quantity squared equals 46. Does anybody else have questions about 1 and 2? Okay, so for number 3, I'm going to leave it zoomed like this because I see some of you are still writing, but in the video it is zoomed in a little bit. For number 3, I have 5 root 50 minus 7 root 8 plus 2 root 32. Anytime you see addition and subtraction with different roots, the first thing you should do is simplify these roots. So I'm looking at the number 50. I know 50 is 25 times 2. It's our goal to find the perfect square factors. So 5 times 10 is not going to give us a simplified version of a root. 5 and 10 are neither of those are perfect squares. So 8 is 4 times 2, and 32 is 16 times 2. Notice that once we simplify these, we're going to be left with all root 2's, which is what we need to have in order to be able to add and subtract these. Make sure that we don't forget about the coefficient that's already outside of my root. So when I when I simplify the square root of 25 to be 5, I multiply that by the 5 that is already out front. When I simplify the square root of 4, I multiply that by the 7 that's already out front. And when I simplify the square root of 16, I multiply 4 times 2 that was already outside of my root. So then I get 25 root 2 minus 14 root 2 plus 8 root 2. Here we have to be careful because a lot of us like to believe that addition comes before subtraction. That's only the case when addition is on the left. Order of operations goes in order from left to right when it comes to addition and subtraction, multiplication and division. So we have to subtract 25 minus 14 first and then add 8 to get letter A, 19 root 2. So if you didn't get all of this down, these notes will be loaded into Canvas. Looking at number 4, in the figure shown below, triangle A prime, B prime, C prime is the image produced by applying a dilation to triangle ABC. Our steps for identifying this dilation are to look at the ordered pairs. And if I were given any straight horizontal or vertical sides, I could just count the units. But because I'm dealing with diagonal lines, I would have to use a distance formula to find the exact distance of those lines, and that is unnecessary. If I just compare the ordered pairs of any of these vertices, which here I used A. So here this is A and A prime. So make sure we understand that the pre-image is the point without the prime notation, and the image has the prime notation. So this is before, and this is after. So if I go from 0.6 to 0.3, that is a reduction, and my scale factor is 1/2. Do you have questions about 1 through 4? All right. So for most of the rest of these, I'm not going to work out every little piece of them, but I'm going to give you guys some guided steps for how to solve the questions. So for this one, we have to be careful because we are given isosceles triangles and I'm given 2 angle measures, but we have to pay attention to which sides are congruent to determine what angles are missing. So our congruent sides are in orange, and if AB equals AC and DB, then that means AC and DB are also congruent. So that's why I put them all in orange. All of those sides are the same length. But if we're looking at just my triangle on top, triangle CAB, where we know that A is 50, because that 50-degree angle is the interior angle of my 2 congruent sides, that means those 2 unmarked base angles are the ones that are congruent. Neither one of those angles, C or B, in my top triangle are equal to 50. Who can tell me what we need to do to find out what angle C and B equal? If they're the same. Yes?
Subtract 50 from 180 and then divide it by 2.
Equals blank and then divide by 2. Yes. So what's 180 minus 50?
130.
And 130 divided by 2 was 65. Very good. So because AB are the 2 congruent sides in my bottom triangle, and I'm given angle D is 55, angle A in the bottom triangle is 55 because that is the other base angle. So if I'm trying to find CBD, this is what the question is asking us. This big angle here. And I know that this is 65, and I know that these 2 are 55. How do I find the bottom missing angle for B? The same exact way I did the other one. This is still triangle sum. So I'm going to have 2 times, let's do this the other way. 180 minus 2 times 55. And that's going to give me angle B for the bottom part. And then whatever I find here plus 65 is going to be my final answer. Does that make sense?
Could you also subtract 65 from that 80?
That wouldn't be the best way to do it because 65 is a part of our top triangle. So if we're trying to find the third angle for our bottom triangle, we need to use the 2 angles that were given. Yes? What'd you get?
B.
Say again?
B.
Yes, 135. All right, so number 6, I'm not going to work this one out with you. Just know that DE is the short side. It's the midpoint. D and E are midpoints. That means AD and DB are congruent. BE and EC are congruent. So 2 times the shorter side is equal to the longer side. So using the information that we're given, we're finding the value of X. Same for number 7. We're not going to work this one completely out. For finding our factor, understanding that Again, when we're looking at ax squared plus bx plus c, and we're talking about the AC method and then grouping, we're multiplying our first coefficient by our last term, which is our constant. Negative 15 times 2 is negative 30. So I need to find factors of negative 30 whose sum is 7. Whose sum is 7. Once we find those two values, we will split up our trinomial into 4 terms. So for grouping, split into 4 terms. Identify the GCFs, and then those GCFs become your factor group. Does everybody remember that process? Or following these steps, you think we'll be able to do it? Okay. So what are factors of negative 30? Negative 5 and 6. So we get 1. That's not going to be 7. What else? 2 and 15. Is that going to give me 7? Even if that one's negative? Nope. So what that would be? There we go. And that will give me 7. So if I have 10 and negative 3, I'm splitting, and let me move this. I'm splitting this into 2x squared plus 10x minus 3, x minus 15. Group them. So if it was a GCF of 2x squared plus 10x. What do they have in common? And? Can't take 5 from 2. X squared and x. So then I have left with x plus 5. What do negative 3x and negative 15 have in common? That would leave me with x plus 5. Will that leave me with x plus 5 if I take positive 3? Negative 3. So then 2x and negative 3 become the other factor pair. So my answer is A. Understand that on your exam, if you get to a question like this and you do not remember how to factor these, there's a shortcut. Put it in Desmos. So we're going to put it in Desmos. And if we solve A through D and match, so A 2x minus 3 equals 0, that answer is going to be 3/2. So if we have 1.5, we need to work backwards from our solutions to find our factor pairs. So if I had x minus 5 equal to 0, that means that x will equal positive 5. But here, x plus 5 equals 0. That 0 is negative 5. So that's how we know that's not the answer. Does that make sense? So if you don't remember how to factor, you can always go into Desmos, find your solutions. And if that's x equals, just reverse it and put the terms on the same side. So number 8, I want you guys to take a second and try and do. So my suggestion for this one is to literally map your points, like start on the graph and just map it if you're not good with the order pair rule. So we can do it both ways. So if I have 1, 2, 3, 1, 2. So this is B. We're starting at B. And we're trying to find it after these 3 transformations. So 1 unit to the left and 2 units down. If I go left and 1, 2, that puts me at D. So this is B prime after my first transformation. If I reflect across the y-axis, make sure we know that that's x and this is y. So if I go across, that puts me here at E. So that's B double prime. Counterclockwise. So if we're thinking about a clock, if this is noon, this is 3, 6, and 9. So if I'm going backwards, that's this direction. That would put me here. So for these, you don't really need to know your clockwise and counterclockwise rotation rules. You just need to know which way is clockwise and which way is counterclockwise. None of those other points, F and A, didn't make any sense for E to rotate to those points. Does that make sense? The only way we would have really messed this up is if we got clockwise, but even then, C wasn't an answer choice unless you were looking at letter C. Does it make sense? So this is one where you guys can request graph paper. I'll have graph paper for you. So if we plot this, we could use the same process. Or you could actually use this graph. Maybe. Is that enough? 1, 2, 3, 4, 5. Yeah, there's enough space there. But just so we know, if I'm going counterclockwise, understand that anytime we're going a 90-degree interval, whether it be 90 or 270, X and Y are going to change position. So I'm going to have YX. And for whatever my original point was, X and Y are going to switch. Now for counterclockwise, if we think about the clock normally goes this way, right? And this is the way I remember it in my brain. Normally, X goes first. So if I have a counterclockwise rotation, Y is going to be negative because that's opposite. That's just kind of how I remember it in my brain. But if we're thinking about on the graph, there's an easier way. So if I know 5, -3, that's going to be 1, 2, 1, 2, 3 here. If I go counterclockwise, that's going to be putting me in this quadrant, right? And if I know that I'm going from XY to YX, these are both positive, right? So even if I have, so I'm not going to have a negative right here. So when I switch these, I get 3, 5. If I apply this rule, 5, -3, y negative x, or negative yx, I get 3, 5. Same thing. Does that make sense? So we can rely on our quadrant to tell us what our signs are. We just have to know that if I'm in this quadrant and I hop just one quadrant away, X and Y are going to switch. If I hop again, it's going to switch again. And then I can use my quadrant to tell me what my signs are. So your best bet is to graph these, even if you graph it by hand on regular blank paper without a graph paper blocks. Like you can still do that. Does that make sense? So if you know you're not going to memorize the difference between when it's -yx or y -x, just use that rule as far as if I go across into one quadrant, X and Y switch, use that coordinate to tell us that X and Y are both positive in quadrant 1. We know that, right, Keelan? So number 9 is C. Because after I have 3, 5, then it says dilated by a scale factor of 2. So that's when we're going to multiply this times 2 and get 6, 10. So number 10, see if you guys can use the quadratic equation to solve this. If I have opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Make sure that we know that this has to be equal to 0 first. Everybody take a second and see if we can solve that one. So guys, here's a little tip. What kind of solutions do we have? Do we have decimals? Do we have square roots? No. So because I have whole numbers, I can factor this. This is factorable. You do not have to use the quadratic formula for this. Everybody log into Canvas? When you get there, open the Desmos calculator and type this equation in. I would move the 4 so that it equal to 0. Actually, do it both ways just to see what it does. How does it behave if we set? Yeah, it doesn't like that. Oops. What are my solutions? Answer is A, B, C, D? B. Yes. So let's use these last 15 minutes to see how much of this we can do in the calculator. Number 11, parabola y equals x squared is changed to the form y equals a times x minus p quantity squared plus q by translating the parabola 3 units up and 4 units left and expanding it vertically by a factor of 2. What are the values of a, p, and q? So because this is asking us for the values of the missing variables here, that graph isn't going to mean a whole lot to us. This is more so about us understanding what it means when we go up, left, or stretch. So if we're thinking about A, P, and Q, do we think A is when we go up, left, or stretch? Which one does A control? The stretch. So that's going to be A equals, if it's stretching by a factor of, then A equals. So what answers can we rule out? So inside the parentheses, X minus P. Is that controlling when we go left or when we go up? Left. So if I have minus P and I went left 4, what do we think? Am I going to have C or D? D. And that made it easy for us because it put P as 3. So the tricky thing would have been if I had been given P equals positive 4. How many of you guys would have chose C if that had P equals positive 4? Good, because we know left is negative, right? So number 11 is D. Number 12, this is also not a calculator question. We need to remember that if I have x to the negative anything, this is going to move it across the line. It has to be in the denominator. So what can I rule out based on that information? A and B. If I have x to the AB, that's going to be index is the denominator. A is the exponent. So the number on the bottom goes in the root. The number on top becomes the exponent. So what is my answer? Say again? D. Very good. Okay, so we're going to do one more, and then I'm going to print these notes I have so far, paper copy, and then at the end of fourth period today, I'll add the file to Canvas because we're going to pick up where we left off in first period, and you guys can watch the fourth period video for review. Whatever we don't finish in fourth period will also still be worked out and posted before you guys, because you guys' exam isn't until Thursday. So you guys will still have time. How many of you guys have exams tomorrow and Wednesday? Good. You got like all day? No? Okay, good. Got both days? Anybody got exams both days? Okay. So just make sure you're getting lots of sleep, eating breakfast, study when you can. Don't overstudy. That's the thing. If you overstudy, you're going to wear your brain out and you're going to go blank when I put this test in front of you. So don't overstudy. So which statement is incorrect? So if I have sine y, so if we're looking at the sine of y, is A hypotenuse, opposite, or adjacent? If I can draw an arrow to it, opposite, which makes C adjacent. Is that sine? No, not at all. But if we have, what did it say? Oh, I'm silly. That is correct. That is adjacent. But what is it asking us for? B is the hypotenuse, and sine is SOHCAHTOA. So this is opposite over hypotenuse. That's correct. Tangent of y, opposite over adjacent. Is that correct? Letter B, opposite over adjacent. Is this Pythagorean theorem? No. Oh, see, they messed with us again. This question is more complex than it was supposed to be. Nothing like, it won't look like this on your exam. It'll be more straightforward. And that was a trick question because it put B as the hypotenuse. So yes, that one is correct. So based on process of elimination, we had to figure out that it was C. So for questions like that, we have to make sure that we're double and triple checking all of our variables and not get slipped up by any of that information. Does that make sense for that one? Okay. So understand here, I want to do this one too because this one is tricky. BC is 12. AB is 20. How do I find AC? This is a right triangle. I'm not giving any angles. What do we know about the three sides of a right triangle? Letter D? The Pythagorean theorem. So if I know a squared plus b squared equals c squared, and I'm given a leg and the hypotenuse, this can be 12 squared plus b squared equals 20 squared. So this, if I just make that b. Yeah, I don't know. It does that sometimes. That's weird. So if I want to solve for b, B is going to equal the square root of 20 squared minus 12 squared. We can put this in Desmos. I don't even know why I did that. I can put, so SQRT is a shortcut for square root. So what do we get? 16. B is 16. So if this is 16, I want to know to the nearest tenth of a degree what the measure of the smallest acute angle is. So if I have a right triangle and I have all three sides and I'm trying to find the missing angle, I need to use my inverse trig functions. Understand that the smallest angle is opposite the smallest side. So which angle is the smallest, A, B, or C? Opposite the smallest side. What's the smallest side? What's opposite that? Oh, it's frozen. A. I drew an arrow. And this is a 6, not a 10. So I'm trying to find the measure of angle A. So even if I didn't use this to find 16, I can find the measure of this angle because I know my opposite and hypotenuse side. I could use sine inverse of opposite over hypotenuse to find what A equals. Sine inverse of opposite over hypotenuse, because sine A is opposite over hypotenuse. When we're solving for A, and the step where we divide by sine, that's when we use the inverse. That's the exponent of -1. That's the exponent of -1. So whenever we're trying to find a missing angle, we have to use our inverse trig functions. So when we do the inverse of sine 12 over 20, what do we get? C. Very good. So take a second to look through the rest of these. I'm going to go ahead and stop the video.